This is Adam Kerner with cadartisans, and today we're going to use Subassembly Studio to construct a subassembly that consists of a fill slope that extends from the insertion point down to an intercept on a target surface, and then we will compare the offset of that intercept relative to the insertion point, and if that distance is greater than a user-defined maximum width value, then we will back up, remove the slope, construct a retaining wall at the maximum width, and then reconstruct the slope to intercept the back of the retaining wall. So with that, we'll go ahead and reset our geometry, and we already have the parameters defined: maximum width, retaining wall shape code, a slope top code, and then a target surface. So the first thing to do is to add the initial slope to surface. And so we'll set that. We want a top code on that, so we'll set a reference to our top code parameter. And then we want to set our layout delta offset to 12, and then a slope. And last we set the target surface. Next is to add a conditional into this, and so that's a logical flow component. And a conditional is basically just a simple if-then. So we will add in a couple of values here to control the size of the glyph on the screen. And our reference point is already set correctly, so the only thing left to do is set up our comparison. And we want to compare the offset of point number 2. And we want the absolute value of that so it works on both the left and right sides. Compare that to our maximum width. And we want to compare that using an operation or comparator of greater than. And we'll go ahead and say OK to this. And so now that creates that glyph. We're going to now attach a rollback operation to point number 3, which is our true path from our conditional. So we again add a logical flow component. This time we select a rollback. Our reference point will be number 3. Our target point will be our origin, point number 1. And so now we have that there. Now we need to locate the face of the retaining wall. So we add a point, and this will be done using a slope offset. So we'll pick that right here. We want no link on this one. Reference point number 5. Our offset will be our maximum width value, and then our slope is the same slope that we used before. Now that we have this, we can locate the top of the wall. So we add a point by delta elevation, delta offset, and we just set in the geometry for the face of the wall that locates the top. And we'll just go up by 1/4 of a foot. We will repeat this, and we will this time define the top of the wall with a delta offset of -1/2 a foot. And after doing that, we need to locate the point where the slope intercepts the back of the wall and construct the slope. So we add another point, this time again by slope offset, and we have a link code on this one. We'll set that up to match our other top link. And then our reference point should be number 5, which was our rollback point. We have an offset that matches the offset of point number 8, and our slope should be our slope parameter. Now that we have that located, we need to locate the point at the face of the wall where it intercepts the slope, or excuse me, where it intersects the surface. So we add a point. We'll do this as offset on surface. We add a link, no codes. We want to reference point number 6. Layout delta elevation, we'll go with -2. And then for offset, we should match the offset of point number 6. Once that's constructed, we need to construct the geometry of the bottom of the wall. So we'll go ahead and do that. We'll use a series of delta elevation, delta offset, and offset delta elevations to do this. So I'll just go ahead and run through this real quick. Okay, now that's done, we need to just add our closing links and define our shape, and then we'll be done with this subassembly. So we'll add a link here between point number 14 and point number 9, and it does not matter which order you put these in. We will repeat that one more time, and this time it'll be between point number 9 and point number 8. Last step, we will add our shape into this. And so that's going to have a code associated with it. That is our retaining wall code parameter. And then we also need to set our link IDs before we quit this here. So let's go ahead and go into here. And it doesn't really matter what order we put these in, so I'm just going to go ahead and put them in here, starting at the top and working around clockwise. Add those in, go ahead and say OK, and now our shape's created. So the last step is to simply export our subassembly out for use with Civil 3D. And for that we just export the catalog. We can select the platform if we want to. I'm going to leave it at 2010. I'd say OK to this. We give it a name for the archive file that's created that contains all of the subassembly files necessary for redistribution. So we'll go ahead and save that. And we will distribute to this machine. And it put all of the files into our AECC content directory on this machine. Okay, now that we have our subassembly completed, we can go ahead and import it into Civil 3D. I've gone ahead and opened up a project and opened up the content browser. So we just go to Add Catalog, we'll browse, and we paste in that directory that we deployed everything to, which corresponds with our AECC content directory. Select our ATC file that was generated by the Subassembly Studio. Open that up, open up the catalog, use iDrop to drag that into a new palette, and now we can go ahead and insert our subassembly into our model. So we'll do that on both the left and right side. Because we have a target surface, we need to modify our corridor properties and set that target. So we'll go ahead and do that and apply it. And now you can see we have a corridor model that has the shallow case up here where there's no retaining wall, and then once the width of that slope exceeds that maximum width value, you can see that it's truncated at that value. The retaining wall is inserted, and then the slope is intercepted to the back of the retaining wall.